Then I must test a theory on you. I have the theory of it is a little bit of a contest. Who has the biggest press right now? I always made a rude comparison. You know what we guys say, sometimes. But we saw it, between World War I and World War II, that everybody was competing who could actually cast the biggest cannon. And
Yep.
Of course, Germany won, and making a cannon that you can shoot one shot with. And it shot almost from Paris to London or something. But anyway, anyhow, there's always been an engineering competition. Who is first in space? Who can send up two people and coming back in not one? And who actually was first in space with a dog, circling around or Leica. I kind of agree very much with you, because sometimes I feel that engineering is not keeping track of the size increase of the die-casting machine. If we took a step back, started to look, made a proper engineering, the gating, projected area, the metal, blah, 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 all these things, we probably end up in maybe a smaller machine. And what does it mean? Well, less money, easier to control, everything gets a little bit easier. So I kind of agree with you, but don't you think that the reason why we see very many of these contracts is that people actually do the engineering, they put a safety margin on it, and they so desperately also want to be the guys with a bunch of 9,000-ton machines? Hello and welcome to Gold Casting, the pod about die casting industry, and also welcome to the special episodes about Giga Castings, even if some people call it mega castings or humongous structural castings per se. and today we are very happy, because what would a discussion about this industry and the Giga Castings be without actually talking to the real guys that are delivering these big die casting machines? And so today's episodes, we are very, very happy to welcome you, Peter Sell. We know that you are Mr. North America for Italpress Gauss, or the Norcan Group, so if you will. We know you a little bit, but I think some of our viewers don't know you. So could you please introduce yourself a little bit?
Sure. As you said, my name is Peter Sell. Good last name for being in sales, right?
Definitely.
And I am the North America sales director for Italpress Gauss. In other ways, for Norcan Group, which is a parent of Italpress. We in Norcan Group, we have 5 different divisions. If you care to look it up online, you can learn all about us. As far as my background and experience, I've been everything from a tool maker, tool designer, plant manager, production manager. So I've lived in the trenches, and somehow, inadvertently, I wound up in sales, just about as direct as of a person as you can meet. And specifically, Italpress, we're trying to reintroduce ourselves, Italpress Gauss, into the North American market, Canada, US, Mexico. We once had a very strong presence over here, and we let that go somehow through transitions and acquisitions and all those types of things. But just as strong as ever. But that's kind of my current was reintroducing ourselves into the North American.
And then ending up in a situation in the midst of the transition, also in the industry, which I find pretty great right now.
Well, actually, I came from the stamping industry, and as the plant manager of a stamping plant, we also did die castings within that same facility. So very familiar with both of them. All of those things interact with each other, specifically EV and rotor die castings. So putting aluminum inside of steel was a little bit of a tricky process, but people have been doing it for forever. So, and now with the die casting, all of the lightning effects of vehicles to improve gas mileage, of course, all of the EV introduction, what everybody's trying to do in that area. It's an interesting time to be specifically in die casting machines, tooling, all of those things that are related to.
So, I mean, the elephant in the room or the casting at the trade show, or I don't know how to put it. But
Well, elephant in the room, the 800-pound gorilla.
Exactly. And you know, one has to be a little bit careful, because if you're in Switzerland, for example, speaking with someone, then it's mega castings, and if you're in Italpress or your colleagues Idra, then it's giga castings. So let's call it giga castings for now then. Open question here, Peter. What is your feeling about these giga castings and your thoughts?
That's it's certainly an interesting question. My thoughts. Italpress designs and builds a press up to about 11,000 tons.
Oh,
pretty big press.
Hmm.
But that's really not the sweet spot for us. But we are paying attention to the industry, what those industry experts are saying, where they're headed. Everybody's demanding bigger presses. So certainly we're going to participate in that area. Do we think that it's the end all be all? Probably not. It's important. It's a few players out there, our customers, they're demanding those sizes, but it's really like few and far between. It's not going to be like there's going to be like the 1,200-ton presses that there's literally tens of thousands of them around the world producing these size parts. I'm a visual guy. These size parts, these size, you get these really big machines, and you're going to have to produce a really big part. And those really big parts, they introduce their own intricacies or problems, if you will. You're trying to push a lot of aluminum into various different cavities, and so it creates, well, just that. It creates problems. And I don't know that the industry experts, all of the industry experts, have enough knowledge on all of the different variables that are going into that part to be able to do that successfully. It was a really long answer, wasn't it?
Yeah, but it wasn't. You saw we were quiet, right? We were like, okay, let's listen here.
Especially, you left us a lot of breadcrumbs to pick into, and that's what I want to do now. And
there you
the question I have for you is, you said as you scaled up, you run into more and more problems. Where do you see the limit? Or is there no limit in die casting sizes?
Oh, if we would have seen limits from engineering back in the 60s, I don't think we would have ever made the moonshot, right?
Of course.
So what those limits are is only to the imagination. Is somebody out there thinking of how do I take that little matchbox scaled car that's cast and just make it bigger? Just make it lots bigger.
There's a small difference if you have a one-time activity sending something to the moon, or you have a continuous process where you want to make money with it.
There you go. Yeah, absolutely. And that's where the differences are between scaling up a matchbox to something you're driving down the road. There's all the little toy that you're playing with in the backyard is one thing. The thing that you're driving people down the road in, that has to have its own insurance rates and repair costs and, all of those things. Boy, it's a whole different world. It's a whole different world. So there's a lot of questions that are going to need to be answered in regards to how you make money. Because let's face it, I say this to customers all the time. Your machines don't make parts. They make money. And if they're not making money, they're probably not making parts. So it's one of those. And if they're making bad parts, you are actually losing money. So it's kind of all of those things. Going back to when I was a plant manager, I said that all the time to employees all day long. Don't think of that piece coming off of the end of that machine as it's a dollar bill. It's a $20 bill. It's $100 bill. But think about it that way. And how many of those $100 bills would you make wrong?
That's a good analogy. And especially it becomes very expensive if these come back.
Oh, yeah.
Because there's a problem with it. Your processes are not in line. and you have to glue more money to it to send it out.
Yeah. You get into the automotive, talking about years ago, it was a big deal with the airbags. Big recall. I know of businesses that went out of business because they had those recalls within those major OEMs. Well, now all of a sudden you get a die-cast component that's, get wild here, the entire underbelly of a car. You're not just bringing it back in and repairing it. You're bringing it back in.
And do some switch or sorba or whatever you like to call it. You have to grind the machine, the whole car down and start again.
Start again.
So,
I was working TV set production, and then it was the same. Do you remember when the flat screen came? That it was fairly expensive with a small one, but when you sized up, the cost went like this.
Right.
And it actually is the thing that the bigger the surface, the higher probability of a defect. Exactly the same thing with these castings. That if you do two shock towers and weld them together, you get probably more or less the same projected area. But if you do one casting, what are the chances of actually having a malfunction or a bad casting around the tower or someplace in this casting? So maybe weight is not that super critical. The surface, the projected area is actually the key here, I think.
And also there's a dependency on the flow length. The longer the metal flows, the higher the probability that a defect is there.
Yeah. And those things, clearly you guys understand those things because you've been dealing with this for a bit. But that's what we try to take into consideration is that, okay, you're asking us for a bigger machine to do these bigger parts, which is all well and good. Are we sure? And we tend to do that. We tend to say, are we sure we want to do this? Because bigger isn't always necessarily better. More is not altogether good. So I know of a company here in the States that they're doing bigger parts on a smaller machine. Think, okay, well, what advantage is that? All of their ancillary equipment doesn't have to get larger. All of their tool room equipment, all of their forklifts, all of their tool change, all of everything that they do, they can keep the initial investment costs lower because they're not having to take care of all these other things. But they did that through the engineering or technology and their shot ends, their shot sleeves, being able to push that, their melt furnaces, the technologies that are going into them, the constant temperatures, and keeping all of that in their tooling, their runners, their cooling chambers inside that tooling, their flow of that cooling is so much better. They've done all of that through their engineering of the tools and the ancillary equipment. And now all of a sudden they're able to do these on smaller machines. So when you ask the question, big is big enough, how small can you get away with? If I can put the same size part in a 5,000 ton press and do it well, I really don't need to build a 10,000 ton press or any of the ancillary equipment to keep, to take care of those bigger things. So.
No, it almost sounds like you're employed by Contic Rio Casting because that is one of our standard argument. Don't buy a 9,000, buy a 6,000 because that's what you get by using Rio Casting.
And seeing the price inflation, probably can buy 2 6,000 ton machines before you get one 9,000 ton machine installed.
Probably. But Peter,
I'm going to say this while I still have it in my mind. Years ago, I was a design engineer designing tooling for a stamping application. And I was told that we have a 60-inch bed length and we've got to stuff everything we can stuff into 60 inches. As an engineer, I kept saying, no. We shouldn't do this. We shouldn't do this. We shouldn't do this. And as it turns out, we did. I got it all in there. The thing never ran with it. I mean, it was horrible. It was just horrible. And so that's what I take into the machine design today. All of the equipment is so much better than it was. I've been doing this for, I hate to admit it, nearly 40 years. But that's what I take from, 20 years ago into today is that, okay, just because you can doesn't mean you should. So I kind of got off track there, but yeah, I think it's important to do all of the engineering that you need to do to fit the right size part or mold into the right size press to adequately do the job. That's all of this little details going into it is so important for the result.
But then I must test a theory on you. I have the theory of it is a little bit of a contest. Who has the biggest press right now? I know I always made a rude comparison. You know what we guys say, sometimes. But we saw it, between World War I and World War II, that everybody was competing who could actually cast the biggest cannon. And
Yep.
Of course, Germany won, and making a cannon that you can shoot one shot with. And it shot almost from Paris to London or something. But anyway, anyhow, there's always been an engineering competition. Who is first in space? Who can send up two people and coming back in not one? And who actually was first in space with a dog, circling around for Leica. I kind of agree very much with you, because sometimes I feel that engineering is not keeping track of the size increase of the die-casting machine. If we took a, step back, started to look, made a proper engineering, the gating, projected area, the metal, blah, 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 all these things, we probably end up in maybe a smaller machine. And what does it mean? Well, less money, easier to control. Everything gets a little bit easier. So I kind of agree with you, but don't you think that the reason why we see very many of these contracts is that people actually do the engineering? They put a safety margin on it, and they so desperately also want to be the guys with a bunch of 9,000-ton machines.
Yeah, but and yes, I do agree that there's a competition who can build the biggest. For whatever reason, I think that exists. I've never been an advocate of being first. First is expensive. Second or third isn't so bad when you're looking at the costs of first. So if you just replicate, there's certain countries around the world that are really good at replicating, but they don't replicate the first, right? So I think from our standpoint, if you can do everything you need to do on a 10,000-ton machine, and I can't disagree with more parts may not be worse or bad than one part, or the other way around. I'm not sure where all of that is going to end from an engineering standpoint, but I know that, again, going back years ago, when I did a progressive stamping tool and I had 3 rows, and I did a progressive stamping tool and I had 1 row, 3 was harder than 1.
Mm-hmm.
It just is. There's more. There's more stuff going on. There's more stuff to go wrong. And so, when you look at a bigger casting, more stuff going on. You got to push that metal farther. You got to, the small areas that you're trying to get it into, the venting on these things, or the vacuum on these things. So that's kind of where my mind lies, is that the mega, giga, really big casting, is there a market for it? Absolutely. Are people going to push the technology standpoint? Absolutely. Do you want to be first to the game? Maybe, maybe not.
Mm-hmm.
So, and there's very few of them, by the way. You're just not going to make, the same quantity of really big casting machines or really big tooling as you would, the small componentry type.
But on the flip side, if you have to worry about 70 different castings and stamping parts, put all that brains into one casting is actually then the smarter option, because everybody can focus on one and do that to perfection. But you have to do something, not just have it in a CAD room somewhere hidden away.
You have to produce it. And that's why first to the market isn't necessarily always the best, because there's a few facilities out there doing these very large castings and throwing away half of what they make.
Ooh, that's so interesting.
Gotta be expensive. I mean, I don't know. I'm not running one of those plants, but I think maybe they don't have all of the disciplines in one person. Maybe that they need a guy that has all of the knowledge so that they can get that one casting right. And that's, putting the teams together and all that kind of thing. It's probably a larger conversation.
Yeah, but you're kind of touching on something, but this is my favorite theme, actually. I call it merger of disciplines. And my theory is that 20 years back, if you wanted to start a shock tower production, you can buy a nice machine from you, Peter, and you bought a nice tool from a well-known tool maker, and the alloy from a well-known alloy maker, and with some blood, sweat, and tears, you probably had a decent production of a shock tower. You can actually cherry pick more what you kind of needed, and the product contained the technology needed.
And also you could get the help from the alloy maker, from the tool maker, and from the machine builder that did 20 of these similar castings, get them on site, help you to get started, and 3 weeks later, you have your first A samples.
Yeah, right. But my point is, why I call it merger disciplines, is that if you look at the physics behind a Giga Casting, the flow length, the properties of the flow length, productivity, yield, pressure, flash, whatever, my theory is to become successful, you have to merge much more to find the very small process window for a reliable production of Giga Castings. Because otherwise it will go up and down. And if you have a small part, for example, you see with your eyes, it's trending somewhere. You have poured too hot metal, or you're draining your holding furnace or whatever. A skilled guy saw that and could react and do things. But the smaller the process window is, the easier it is to slip out of the process window. That means that spot cooling has maybe to be replaced by 3D printed cores, for example. You have other surface treatments in the tool. The tool contains much more, and not necessarily not only tool technology, tool making know-how, it also comes into the vacuum channels and how do you actually do a vacuum with a projected area of 2 square meters. So I think we have to learn to work together, and the casting industry, I claim, is too low on competence or people with decent research. I'm not saying from the university, but maybe done the research and the hard way, building 50 tools somewhere. The tool makers,
a combination between the academic knowledge and the practical experience on the shop floor, and combine that. That's something that you find really rarely.
Yeah, but let me take one example. I started as a purchaser. Then, being a metallurgist from university, you ask, okay, what are your properties? The first thing you had was the data sheet from the alloy producer. If you do a structural casting and start to flip around in that specification that says something between 0.1 to 0.5 of a certain element, you have a total different range of properties.
Yeah, in normal steam specification, you get 500,000 different variants of the same alloy.
Yes.
Just within one specification. And where do you pinpoint yours?
So what I'm saying, I'm sorry for talking, we're supposed to interview Peter here, but my thinking is that the ones that will have a financial sound production of Giga Castings will be the ones that could organize for the merger of disciplines.
And Staffan, I would completely agree with you on that.
Oh, thank you.
As you were talking, you saw me smiling and shaking my head. And it's like, you guys get it, but not the entire industry doesn't get it. Because you go into these operations, and typically the guy that's buying the components, he's never run a die-cast machine in his life. So he just looks at the cheapest thing I can buy. That's his job. The guy that's pushing the metal into the machine, he has no idea on the metal makeup. I got 3 different suppliers of metal because the guy in accounting said that I need more than one, because clearly if one goes down, I need to get it from somewhere else. But the metal makeup of those 2 ingots coming in, they're different. And nobody can say that, well, you're inside a certain parameter, because just like you said, at a certain point in that casting, the makeup of that material is going to actually be a little bit different.
It is so sensitive. I mean, if you talk to the guys doing structural casting, it's like it's an art form. It's not like when we were casting for the telecom industry in the late 90s.
Right.
Stamp the parts out, we're putting GSM on the world map. Boom, out.
Yeah. And especially with the alloys, everybody thinks just buying these blocks of aluminum, putting them in the furnace, and then you're ready to go. There's so many things. Usually, first thing the quality department comes in and says, first in, first out, and then you're constantly alloying your alloy. No, you have to go a different route. You have to see, okay, what are the exact parameters, what can be composition from each of the blocks I have, and then mix them together to your most constant alloy throughout the production. And you're not changing the alloy all the time. Then you have to look up how's the production running, how much scrap do I have, and it's just a base metal. If that's already shit, you can do whatever you want afterwards. It doesn't get better.
Yeah, and if you look at the machine guys, I mean, you guys at Italpress and your colleagues, I don't want to be rude here, but I mean, it's been pretty handleable. But now you start to pour 100 kilograms of 710 degrees of aluminum to the same spot in the shot sleeve. And of course, you have to change it every shift or every second shift or every 4 or 5 hours. We hear all the stories as well in this podcast. And I mean, there's a whole technology development to be foreseen here when it comes to computing science, trends in your machine, how to manage quick shifts of shot sleeves, for example. That's simple operation. I mean, when it starts to cost, I don't know, 20,000 euros an hour if you stop the car assembly line on the other side of the wall, it becomes pretty interesting to change that 1 in 40 minutes and not 2 hours, etc., 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 etc. So I think we're looking at 15 years of development, at least.
You have to find so many things when you change something. Which things do you have to preheat that you just put it in, and then when it's preheated, you cannot touch it. There's quite a challenge running something like that and having all these problems at the same time and figuring out and getting ahead and not canceling each other innovations out.
Oh, yeah. Your project manager has to pull together all of these different disciplines and then understand each of those different disciplines to be able to get a good casting on the other side. And that's a big task. And right now, I look at the industry and I've been into, some of the major OEMs. And what I'm seeing is that the knowledge level that needs to take place to be able to do these things economically, meaning making money, we're a ways off from that right now. But the only way to get there is to have these individuals in the trenches that are learning on the fly. They're taking all of their academics right out there to the trenches, and they're working in the trenches to make this stuff happen. So, and the more resident experts that you can talk to within, whether it's a machine builder or the tooling builder, I talk to tooling builders all the time because those guys are really sharp. They know this kind of stuff. So I talk to those guys all the time. I talk to the guys that are dispensing lubricants for your release agents. All of those things. Talk to those guys all the time because every time I talk to them, I gain just a little bit more knowledge to be able to make a better die cast machine and service the customer just a little bit better.
No, there's so many things going in. We also did a lot of trials with release agent makers to get to the point, especially in Rio casting, you have very slow filling speeds, and we have similar timings for the metal that is in the cavity than a Giga casting on a very small machine. So it's cheaper to try it with that and get the right release agent done. But I wanted to comment on another thing you said. Being in the trenches, that sounds like war and something negative. And it's the totally opposite. When you come, for example, you know it from the lectures, going down in the machine hall, pressing the knobs, turning metal around, that's the most fun you can have. Do it. There's no shame to go in after you get your academics degree and going into the production, doing something with your own hands. Do it. It's so much fun.
Years ago, when I was a plant manager, I told people on the shop, they were always surprised when I was out on the shop floor running a machine. Always. Well, you got this big title, you got this big position. Why are you on the shop floor running this machine? Well, I can't tell you how to do it if I don't know how to do it. I can't. I don't know what's wrong if you're just coming in and telling me something if I haven't experienced it. So it's always good to be on the shop floor with the individuals that are in a daily situation out there on the shop floor. And removing as much complexity from an operation as you possibly can.
Oh, yes.
Remove the complexity. It will make your plant run better.
I would like to address something else and a direct question to you then, Peter. I mean, you said that sometimes the office seems a little bit thin on competence or number of heads working on these things. And I totally agree. totally agree. But aren't the problem that there are not that many people you can hire
Oh,
to recruit? I think we have a big recruitment problem. Would you agree or not agree?
Oh, it's a terrible situation. Young people have the wrong idea about where industry or manufacturing is today, especially here in the U.S. You know, they get all these horror stories from people that lived in these shops back in the 50s and 60s, and they don't realize that you walk into these facilities and they're immaculate, they're well lit, they're nice places to work. So there's a disconnect from that standpoint, and then getting people just to go into the manufacturing or the industrial trades, it's a little bit of a trick. I tell people all the time, you want a lifelong career, become a tool maker.
So that is your advice to a young guy that feels like, this casting industry looks interesting. So you would say, go to tool making.
Yeah. Be a tool maker. Get a 4-year degree as a tool maker. It worked for me. It worked for me. I don't know. And not that I am ultra successful, but I've made a career, provided for my wife and 2 kids, and it's still fun. It's still fun. It's still enjoyable. It's still challenging. I mean, after 40 years in the industry, so and I know that exists on a world scale now. Of course, when I was young into it, it's just the U.S. You can go around with an engineering degree or a technical tool making type of a certification. You can travel around the world. You can do a lot of things. And like I said, reluctantly, I'm in sales. But it was really because people kept saying, "You explain this really well." Well, I came from the manufacturing side where it all happens, and just trying to be upfront and honest with people as long as I can. Personally, if I have something, the company I represent has something that you need, I need to connect you something. That's all. That's all. Just connect you something. I don't need to sell you a used car. I'm not that kind of guy. So yes, I would encourage young people to go into a technical field, something that will challenge you for a lifetime, and it will take you in a different direction. The same guy that went into tool making 1983, completely different person at 2024. But it takes you from there, from then to now, and kind of things. I would certainly encourage people, anybody to go into what we do, diecasting, manufacturing. We chased it from the U.S. down to Mexico over to Asia, around the world a little bit. It is all going to settle out. And yeah, if we could keep the guys that know nothing about manufacturing out of manufacturing, it would settle out a lot quicker.
Yeah. If you would stop doing these PowerPoint engineerings, the world would be easier and we would be way far ahead. On paper, it sounds too good.
It's very easy to move a big die casting machine on PowerPoint.
It's quite easy. Right-click, size, to slide, and then you have it there. But being on the shop floor,
you guys get this.
Yeah, but I'm a little bit curious. You're building an 11,000 ton machine. Can I get it? It's not a prototype that you will have for just fun in Italy. So could you at least reveal which continent it's going to?
We have it on paper, and we've got quite a few 4,500 tons out there in the industry doing everything that we need to do. I'll say this on here. We got one of the best shot ends in the industry, and that's no joke. That it is, and that's where all the action happens, is in your shot end.
Yeah.
How you're putting that aluminum in there.
If we put it like this, isn't the locking force just to absorb the mistakes before in the process?
Well,
in a way to see it.
Yeah, but if you don't have the right shot end, doesn't matter what clamping force you're using. if
you will never get
if
the
you
metal in there.
get your metal in constantly and in a continuous acceleration, you're screwed.
One of the products that we've got out there is obviously our toggle-free design. And if you go through the engineering on it, it makes all the sense in the world. And that's all you can do is look at the numbers and look at the design of the press. And, you go back, I think we developed that in 2008. Prior to that, everything was a toggle machine. And it was monumental advancement in technology on a die-cast machine. So much so that we like to guide all of our customers to that toggle-free system, and we can back it up with the engineering as to, it's not just, hey, this is a new design, let's go with that, kind of thing. No, it goes right back to the engineering, and if you can't prove it from an engineering standpoint, then it's probably just a salesman talking. So, but yeah, the toggle-free system, I think that you will see in the next 10 years that certainly all of the bigger machines and even some of the smaller machines, when I say smaller, 1,000-ton, anything less than that, they'll stick with what they've got for how long. But the really small, cheap machines that don't take a lot of closing force, those other machines are just fine for the bigger ones. You probably need to go something better than the toggle system, as long as we're talking about machines, I guess. If I was to recommend to a customer, buy the absolute best shot end you can buy. Your shot control, your shot monitoring, your everything data-wise that you can pull from. We've got a system on our machines. We call it Monetizer. You should have that on your machines. You don't know what to do if you don't know what's going on. And so, connect yourself.
But you cannot track, you cannot manage. And if you don't have the data, see the trends of each of the parameters, it's impossible to control a process if you don't know where it's going.
And something when you're getting down into the details that you're, for you as a human being to try to be able to manage it, if you can't see it, but if you track it with a computer of some kind on your shot end, you can see just exactly what makes a bad, what makes a good. So those are very important. If I was running a plant, I'd have one on every machine. Simple as
but
that.
If you see the cost levels are somewhat evening out around the globe, we see transportation costs is being more, not only higher, transportation is a little bit more complicated with the wars going on and other stuff and trade wars. We probably start to really see more a competition on what's actually going out of the machine, that dollar bill that you were talking about. Before, you can have been in a super low cost country. If you cast a 50% scrap, that was not a problem. You were still competitive. I don't think this is true anymore.
It isn't true anymore.
You don't find that remote area with a salary of $1 per hour anymore.
Yeah, when our business was moving from the U.S. to Mexico, it was about a 4-to-1 ratio. It took 4 individuals to do the same amount of work as up here. It was about a 4 ratio. Everybody moved there, and then their costs went up, and then it moved from there to elsewhere in the world, and so now it's coming back again. It's coming back to Mexico. Ultimately, will it come back to the U.S.? It's hard to say. I mean, it might stop in Mexico and hang out down there for a while, but we're so close that the transportation cost between there and here really doesn't mean a whole lot anymore. So, so we'll see how the manufacturing as a whole. But there's a whole lot of manufacturing, certainly a whole lot of die-cast components that are still here in the U.S. and they survived all of that. So, do I think that it will pick up here? Absolutely, because of transportation costs.
I think there's another thing to it. I will make a statement and I would love to get your opinion on that. Usually, if you have the complexity increases with every generation, parts get bigger, more complex, more things get integrated. And if you always pick the cheapest one that's furthest away, you have a double shot in the foot. Transportation costs are rising. And also for the next generation of that product, you won't get any help from your local suppliers.
That's right. Yeah, and that's definitely right. You won't get that support or from your local vendors. That's the crystal ball that we would all like to look into and figure out, okay, where is all this stuff going to drop? 10 years, we'll know.
I think you have a much stronger factor in product development cycles, because going to EVs means that you have unmatured designs. It will be a hell of a lot of design changes, small stuff, big stuff. And then putting components on a boat from China, ship it to the US 3-4 months with customs. You have a problem. I mean, the telecom industry actually learned this. So either you have to design the facility 2 hours by car to your suppliers, or you move in and have suppliers around your design office, because changes are that quick. You cannot be quick enough. So I think this will be a driving factor as well, that you need, as Fabian is saying, the support. Yes, offshore from your supplier, because you need to ask something. Is the draft angle okay on this power or whatever it is? And then having 3 months of supply on a boat when you have a critical problem, bad luck. Try to sell it back.
Yeah, I mean, just recently somebody run into a bridge out on the East Coast here in the U.S. and port is completely shut down.
Yeah.
I had a press going over to Asia, and the canal was shut down because there was a boat stuck in it. I had a customer calling me every day saying, "Where's my press? Where's my press?" And I pulled it up on the world view and said, "It's on that boat right there, right there." That's where it is. I don't know what you want me to do, but that's where it is. And so those kind of things happen. They could happen,
Yeah, but you had German car producers that 100% of the cable assemblies came from Ukraine.
Right.
They kind of had a stop in supplies for a while.
Right. Yeah, you get into all of those kind of things. So
yeah, and things happen. That's the only thing you learn from history. Things happens all the time.
Yeah, then that's even more important today to build resilient processes and also do some risk mitigation. See, okay, when we have just one supplier that delivers from one location, maybe you have the same supplier but different locations, so that if something happens to a bridge or the Panama Canal is out of water, you can deliver it from the other side of the world.
Yeah, there's a great difference going from 100% down to 20, 30, or 40, and going from 100% down to 0. Believe me, I've been an operation manager for that many years, and I know that as soon as I have something for my most precious customers to be able to put in a box and ship, at least I'm standing on my 2 feet. But when it's 0, you can start to pack your desk.
Yep. That's a good way to look at it.
Yeah, really. So interesting discussion, guys, and we're 3 guys here with a lot of knowledge. At least the 2 of you. I'm just a sales guy, but you kind of get the feeling that we will revert back to this.
Hey, I'm just a sales guy.
I'm just lazy sales guy.
I've got that title.
Yeah, but I'm the head of marketing and sales at Comtech, and you're looking at 100% of that department.
Yeah, and I have
also, we said in the podcast you never should mix the marketing and sales department.
and I have the right last name, right? So that's how I started. I was actually I was born into this thing. So.
Yeah, you did. You never had a show. You're like the royal family in Sweden. You're born into it. You're going to be king, regardless if you like it or not.
Sure. But
King Carl
I've really enjoyed being on with your segment here and having the chance to hopefully get some industry knowledge out there to the masses.
The pleasure is ours, Peter.
Some ideas out there to the masses. I love this stuff. I just love this stuff. This manufacturing thing. It's like I said, it's been a lifetime. And if I could share with anybody on the planet, it would be younger people, to try to get them kind of charged into going into something special, going into something rewarding, going into something that provides for them and their families. Yeah, good stuff. Good stuff, guys.
I think that's a brilliant ending of this episode. And And again, Peter, thank you very much for spending time with us and being here. We have enjoyed it very much, and I hope that we will swing a beer on the NADCA show when we're getting over there in September. Just planned it this morning, by the way. So we're having a booth there. So let's meet up.
Right?
Let's have
my kids will be there in Indianapolis. So I'm really looking forward to going down there and having that show and swinging a beer with you. That's all good stuff. You should come over in May. We might actually get out to the big circle.
Well, traveling is a little bit difficult right now when you are also the sales and market department is one guy and you're servicing 32 OEMs.
Sure.
It's complicated.
Absolutely. Anything I can ever do for either of you or anyone else that you know, don't hesitate to throw the name around a little bit, and I'll help anyone in any way that I can.
Oh, thank you. I appreciate that.
That's perfect. Thank you. We try to put it out to get your knowledge into the world with that nice podcast episode. And I think we can close it for now. And maybe if there's more things coming up, more knowledge coming down, maybe we don't wait 10 years for the next episode, but we can do every time a follow-up when there's new knowledge, new tendencies. And up to now, thank you for listening and goodbye.
Thank you, Peter.
Thanks, guys. Take care. Bye now.